Welcome back to part 2 of my introduction to Senary primes. So if you're wondering what Senary means, Senary just means base 6. Some people might say hexamal as opposed to decimal or something like that, but Senary is probably the best term for it. So this is a game board from a game that I made on my website called Man Home. You can check it out if you want. I'll put a link in the description. And I'm just using it to illustrate how I like to view the number line. So you can see the integers here listed out left to right, and then it goes up to the next line and up and up. And the prime numbers are bigger. They're in bold, I guess you could say. And composite numbers are this smaller size. You can see there's 6 columns. So the numbers are laid out in a Senary fashion, but they're still written in decimal just to make things easy. So at the bottom of these 6 columns, I have some labels here, 2 and 3, 2, 3, 2. And this tells us that everything in that column is divisible by 2 and 3 here. And the 2, 2 columns, they're all even numbers, and they're divisible by 2, but not 3. And then this 3 column, everything in this column is divisible by 3, but not 2. So the 2 columns we have left that are blank, not labeled by a 2 and a 3, that's where the remainder of the primes live. So if we look at these primes in this column, 7, 13, 19, they're all one more than a multiple of 6. So I would call those positive primes in the Senary system. And all of the primes in this column, we got 5, 11, 17, etc. I would call those negative primes because they're always one less than a multiple of 6. Let's take a look at how the prime numbers move through this Senary number line. 2 basically goes every other column, 2, 4, 6, 8, 10. Whereas 3 bounces back and forth between this 3 column and this 6 column. 3, 6, 9, 12, 15. Okay, 5 goes up and to the left, 5, 10, 15, 20, in a straight diagonal line. And you were probably wondering what these diagonal lines are. Well, that's the path of 5 going up and to the left, and this one going up and to the right, that's the path of 7. You can see we got 7, 14, 21, 28. Our next prime pair, 11 and 13, they move like knights on a chessboard. So they'll go up 2 spaces and over 1. So 13 goes up 12 plus 1, up 12 plus 1, up 12 plus 1, and then it goes again. Whereas 11 goes up 12 minus 1, up 12 minus 1, up 12 minus 1, up 12 minus 1, up 12 minus 1. So there goes 11 and 13. Our next prime pair, 17 and 19, sit on either side of 18. And 18 is 3 times 6. So all your primes are going to be some multiple of 6 plus or minus 1 here. So here you can see 17 is 6 times 3 minus 1, and 19 is 6 times 3 plus 1. And that tells you how it moves. So let's follow 17 up the board. It goes up 3 multiples of 6 minus 1. That gets you to 34. And then 1, 2, 3 multiples of 6 minus 1, there's 51. 1, 2, 3 multiples of 6 minus 1, there's 68. So let's check out 19. We'll start here. And it is 1, 2, 3 multiples of 6 plus 1, there's 38. 1, 2, 3 multiples of 6 plus 1, 57. And now we're off board. So 23, our next prime, is 1 shy of 24. But on the other side of 24, we don't have another prime. We have, well, 5 squared. 25 gets knocked out by 5 here, so it is not prime. But we can see how 23 moves. 6 times 4 minus 1. Let's check it out. 1, 2, 3, 4 minus 1. There's 46. And 1, 2, 3, 4 minus 1. There's 69. 3 times 23. Okay, next up, sitting around 30, we have another prime pair, 29 and 31. And 30 is 5 times 6. So that's how these guys are going to move. You can see I have that written over here. So let's try it out. 29. 1, 2, 3, 4, 5 times 6 minus 1. There it is, 58. And we're going to start going off the board pretty quick. 31 is 1, 2, 3, 4, 5 times 6 plus 1. There we are at 62. Moving up another multiple of 6, we go to 36. And plus 1, we do have a prime number, 37. But minus 1, we don't. We can see this is where 5 and 7 meet up. That's this crisscross right here. But 37 is 6 times 6 plus 1, and that's how it's going to move. And we can count 1, 2, 3, 4, 5, 6. Oh, would have been right here. And now we're starting to get prime numbers that we're not going to see their multiples anymore because this only goes up to 71. So that's pretty much it. That's how all the primes move. They are some multiple of 6 plus or minus 1, and that's how they would move in a Senary situation like this. So we can see next we've got 41 and 43. They sit right around 7 times 6. They're a prime pair. 47 doesn't have a prime pair because there's 49 is 7 went through it there. That's 7 squared. And we got 53 doesn't have a prime pair because that's where 5 and 11 meet up. We do have a prime pair around 60. So 10 times 6 we have 59 and 61. That's pretty cool. 67 is going solo here, right around 66 because at 65 we have 5 and 13 meet up right here. And then 71, it has a prime pair too, 73, but you can't see it. So this is the main advantage of looking at all the numbers, not just the prime numbers, in a Senary or base 6 system, is this, elegant diagonal movement of the prime numbers through the number line. And you just don't get that in the decimal representation of the numbers. All right, that concludes my introduction to Senary primes, part 2. We'll see you in the next video.